Welcome to a video series, and I guess why wouldn't this count as a podcast, a video podcast anyway? But anyway, a video series on applied rationality. So I'm a mathematician. I'm interested in part just in pure mathematics, but also in applying the lessons of technical fields like math, science, statistics, logic, and also some less technical fields like philosophy and history to, making sense of life and current events. Since this is such a huge and open-ended topic, I want to at least start by anchoring myself to some sort of a structure, like where do you even begin when you want to talk about this kind of stuff? So I have chosen to make the first several videos essentially a companion to the textbook The Data Detective by Tim Harford. Now, I chose this book in part because of how appropriate it is for my interests and what I want to do with this video series. But I'm actually a longtime listener to BBC's program More or Less, which is, of course, hosted by Tim Harford. So I was very pleasantly surprised to see that he had written a book and that, so I could get some more Tim Harford by following this textbook. So that's great. So let's just kind of jump right in and start talking about chapter 0 of the book. And in this chapter, we see a very compelling argument that, in fact, the old tale of how storks deliver babies actually turns out to be true. And here we can prove it with statistics, right? So this is a cautionary allegory, basically. There is a strong correlation between the number of storks and the number of babies. Therefore, storks cause babies, right? Simple causal argument, right? All from data and statistics. Now, I think that when we hear that correlation does not imply causation, it makes sense. We know that storks don't cause babies, right? They don't bring babies into existence. So we know something is up with this. And that's the whole point of this example, right? Here's the trick behind the statistics that show that storks cause babies to exist, and it's that we measure a bunch of countries like Germany and Albania, and we record the number of storks and the number of babies, and the big countries like Germany have a whole bunch of both, and small countries like Albania have a small number of both, and that establishes a correlation, right? Small number of storks, small number of babies, big number of storks, big number of babies makes it seem like they're related variables, and maybe in some sort of roundabout way, they're related through the size of the country, but it's really the size of the country that is kind of controlling both of those variables. So it's not a causal relation between storks and babies. But, okay, so that's great, right? It's a very simple lesson. In fact, I think like a lot of times when we learn this lesson that correlation is not causation, it seems like it's a big kind of duh. Of course they're not the same thing. Why is this even some egg-headed sounding academic lesson? Well, I think I tend to notice that as much as we all recognize the validity that correlation is not the same thing as causation, we then go on in the rest of our lives to not heed this lesson. I have heard so many news programs, usually the bad ones, but even some of the very, very good ones like NPR, I have heard a few occasions where the reporters seem to have failed to catch this concern, right? And seem to have gone along with some research or some report indicating that one thing causes another thing when really all the data showed was that they were correlated. Now, that's just my own personal observations, and I wish I could give you some citations for this sort of thing, but it's been so long since I've seen the specific examples, so it's great that Tim Harford actually has this very outstanding and unfortunate example of such a thing, which is that a paper titled "Storks Deliver Babies with P equal to 0.008." Now, we'll talk about that P equals 0.008 in a second, but the important point here is that this paper was, right, like this paper used the data about storks and babies to show that storks deliver babies. Now, why was this even allowed through the filter of academic publishing? Well, because it had numbers, right? They established correlation. It has a p-value. This p-value, let's go ahead and just briefly describe it as non-technically as I can manage to do so, what it means. It's called the p-value, and it's a measure of the strength of a correlation. It can take a value from 0 to 1, and 0 indicates a strong correlation. So this is a number that is pretty close to 0. If p is less than 0.05, that's a somewhat arbitrary but fairly standard cutoff, so that if p is less than 0.05, often that is considered a strong result. And so this is stronger than strong, right? That's quite a lot closer to 0 than the cutoff. So because this has such a good p-value, right, it's indicating such strong correlation, often, some academic journals will not, forbid a paper when its p-value is that low, even if, people don't necessarily believe in the results and they have some misgivings and blah, 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 they'll still allow it to get published merely on the basis of the strength of the correlation. And to some degree that kind of makes sense because, if it's a really strong correlation, well, then we at least want to know why it has such a strong correlation, even if the relationship is not causal. And so you let the person publish it and see what they have to say or something like that. But it really does ultimately just give too much respect, industrial, right, as a kind of cottage industry of producing and analyzing statistics, this policy of if your p-value is not small enough, we're going to allow the publication. That having that as a policy just gives us way too much deference to the mere strength of correlations. This is a bad thing that would ever get published. Now, returning to other examples, as I've said, I've kind of lost track of all the times when I have personally seen an academic, a politician, of course they're the worst, but journalists as well, intellectuals generally, when they have failed to appropriately discern correlation from causation. It's happened very many times. I've seen it on the news. I've seen it in lots of places, but I can't remember all the places I've seen. I didn't keep a journal. So I would be kind of like entertained and gratified to see if anybody out there wants to go ahead and contribute, right? Leave in the comments of this video whatever examples you've seen in the wild of people conflating causation with correlation and what kind of misunderstandings that might have led to. So that would be interesting to hear from people about how they've seen it in their own lives or on the news. Now, so far, I'm just blaming a lot of other people about their mishandling of statistics. Well, right, you should, not good to just think that, you are some kind of special above it all person. So I'm going to confess that I'm not above all of this. I have definitely heard some news stories and so on, some reports from academics. And I would, hear what they found or said that they found and wonder how they could know that the results were causal rather than correlational. And I would just kind of shrug it off as saying, well, they must have, determined it somehow because otherwise, peers in their academic discipline or other journalists would have vetted this and would have questioned this claim of causation. And if they didn't have a good answer, then it wouldn't have passed all of our sort of filters for what things get published. But we have enough examples to know that mechanism does not work reliably enough. And so we cannot merely trust professionals that they will always do their due diligence and discern causation from correlation. We have to always ask for the argument which demonstrates specifically the causal part of the claim. Now, summarizing, Harford's book goes on to praise the really great classic. I've also read and enjoyed this book, How to Lie with Statistics. So it's it's perhaps the most popular. It's for a wide audience, a book on statistics. It's written by a journalist. This man Huff was a journalist and wanted to explain how people get tricked with statistics, giving a fairly non-technical introduction to the topic. And what I kind of enjoy about it is that often it comes off as like a puzzle or a challenge. Try not to get fooled by the data and the numbers that I'm about to hurl at you, because I'm about to try to trick you. It's a great fun challenge. Here's an example, right? This one still taken from Harford's book, but that in turn taken from How to Lie with Statistics. So in a 1950s survey, Yale's 1924 graduating class earned, it said, an average income close to $500,000 per year. Now that is quite a lot, $500,000 in 1950s dollars. That's a very, very large amount, but it is Yale after all, so maybe it's plausible. Is that it? Do we have to just believe that? Well, of course, no, this is a challenge. And, think about how the data would have been, gathered, right? Are these statisticians or whoever collected this data, are they going to go and use like legal authority to compel records, tax documents to prove people's income? No, of course they're not going to go to such lengths for a survey like this. So this has to be basically self-reported, right? Unless they had some other trick, but there wasn't. There was no trick. They did not do anything more reliable than self-reporting of income. Well, if it's self-reported, of course, people, and especially Yale people, are going to lie very unashamedly about their income. Okay, and that's not the only problem, right? So there's non-response bias, right, so to speak, which is the problem that you may contact a bunch of people and only a small portion of them may respond, and maybe the people who tend to respond tend to be the wealthier ones because they're prouder of their income and want to tell you all about it, and the people who don't respond may be the lower income people. This is exactly the problem that we're always talking about with polling in US elections, non-response bias. Anyway, besides that, they couldn't even send out the survey to every single Yale graduate because some of these people, you lose track of them, right? So who are going to be the easy ones to find, whose addresses or telephone numbers or whatever are going to be the easiest to find? Well, they're going to be the rich and famous. Usually, not always, but there's going to be a statistical tendency that's going to skew the data. Okay, so all of that was a very interesting and I thought fun exercise. Harford then ends this subsection of his book with, so this was all spent praising the book How to Lie with Statistics, and then ends on kind of a dark note that we might start actually criticizing the book in a minute, and so we'll talk about that in the next episode. If you enjoyed this, if you want to support the channel, then please like and subscribe.